Anna, and I will be explaining how the cardiac conduction system of the heart works, and as well as a little bit about pacemakers. So the World Health Organization has stated that cardiovascular diseases are the #1 cause of deaths globally. Having said that, let's take a look at the human heart anatomy. So the heart is the organ that pumps blood throughout the body via the circulatory system. It supplies oxygen and nutrients to the tissues and removes carbon dioxide and other wastes. The heart is located at the center of the chest, and it's usually pointing left. And some interesting facts about the heart is that it's roughly about the size of a large fist. It weighs between 280 and 340 grams, and a heart beats about 100,000 times per day, and it pumps more or less 5.7 liters of blood throughout the body. Interestingly, the newborn hearts beat faster than adult hearts. And while this is the anterior view of the heart, here we can see the right and the left atrium, as well as the right and left ventricle. This here is the tricuspid valve, and this is the bicuspid valve. This here is the pulmonary semilunar valve, and this is the aortic semilunar valve. This is the pulmonary trunk, which divides into the right and left pulmonary artery. This is the aorta, this is the superior and inferior vena cava, and these are the pulmonary veins, and this here is the interventricular septum. So with help of the next video, I will explain how a cardiac cycle is produced by the electrical impulses in the heart. The cardiac cycle starts when an action potential or electrical impulse is initiated in the sinoatrial node. The action potential is conducted from the SA node to the atrial muscles, which causes the atria to contract and pump blood into the ventricles. Then the electrical impulse spreads through the atria to the atrioventricular node, where the conduction slows. And that slightly delay allows the ventricles to relax and fill with blood before contracting. The action potential travels rapidly through the bundle of His to the apex of the heart. This is because the conducting pathway is divided into left and right bundle branches that lie in the interventricular septum. And from these branches, the action potential spreads upward through the inner walls of the ventricular muscles via the Purkinje fibers. And finally, the action potential travels up the outer walls of the ventricles towards the atria, and this rapid and controlled spread of electrical impulse through the ventricles stimulates the muscle cells in each ventricle to contract together and pump blood to the lungs and body. And eventually, the entire heart returns to the resting state and remains there until another action potential is generated in the SA node. So now let's talk a little bit about pacemakers. So what is a pacemaker? A pacemaker is a device that is used in patients with slow heart rhythm. When someone has a slow heart rhythm, not enough blood or oxygen is being delivered throughout the body. Patients often experience symptoms such as shortness of breath, lightheadedness, or even passing out. So basically, it is needed if aging or heart diseases damage the sinus node's ability to set the correct pace for the person's heartbeat. And such damage can cause a slower than normal heartbeat or long pauses between heartbeats. Pacer has different components. One of them is the pulse generator, and it consists of the battery and the computer component. And the second component of the pacemaker is a lead, which is a wire that is introduced into the heart through an artery, and it's attached into the right atria. The third component of a pacemaker is the electrodes, which is a anode and a cathode, and these two deliver the electrical impulse to contract the heart muscles and regulate the electrical conduction system of the heart. Now, specifically, I want to talk about His bundled pacemaker, and which is a new device that enables a therapy called His bundled pacing. It is named after the Swiss cardiologist Wilhelm His Jr., and studies have found that some patients that get the traditional pacing in the right ventricle may eventually develop a so-called pacemaker-induced cardiomyopathy. Cardiomyopathy is a condition that makes it hard for the heart to deliver blood to the body and can lead to heart failure. And this new type of pacemaker intends to prevent the patients from developing this form of pacemaker-caused heart failure. Healthy heartbeat relies on precisely timed electrical pulses in the left and in the right ventricles. Usually a pacemaker lead delivers current near the apex of the right ventricle, which forces the electricity to pass through the heart tissue before it can stimulate the left side. This creates a delay that can elongate the heartbeat and forces the left ventricle to work extra hard to compensate, leading to a weaker left ventricle over time. And his bottle pacing delivers electricity higher in the heart so that the electric pulses from the implanted device can travel along the natural conduction pathway in the heart, triggering a more natural timing in the left ventricle. Just like every other therapy, there are some drawbacks. One of them is that it is more difficult for electrophysiologists to implant a pacemaker. This type of pacemaker may also require more energy than traditional pacing and more time in the operating room. And the major limitation of this pacemaker is that the long-term outcome is still unknown. So, thank you for listening. Here are my references.